Hello and welcome to Func Prog Sweden, everyone. A warm welcome to Func Prog Sweden. If this is your first Func Prog Sweden, then warm welcome. If this is not your first Func Prog Sweden, then welcome back. Thank you very much. Func Prog Sweden is the meetup where we explore functional programming and functional programming concepts. And today, let's head over to today's agenda and we'll see what we have today. First up, short intro by me, Magnus Sedlacek. Then we'll head over to Elixir in the Enterprise, Lessons from Maersk by Erik, Mejer, Hansen. It's going to be very interesting. It's going to be a topic how they introduced Elixir into big enterprise. Then we'll have Electric plus Rama, a Clojure stack from the future, by Felix Alm. Then in the end, if you have more questions, please join the post-show chat where you can ask more elaborate questions if you didn't get an answer in the beginning from the presenters. And now, we would first up like to thank tonight's video sponsor, Adabeat. Adabeat is a consultancy company with office in Stockholm and in Ho Chi Minh City, and they are working exclusively with different FP languages. If you want to know more about Adabeat, head over to adabeat.com or check them out on social media. And of course, we also want to push our own conference that we're going to have in a little bit, I would like to say a month, but it's less than a month, October 15th. Head over to funcprogconf.se and or .com to check out. It's going to be a magnificent lineup, and it's going to be a fun day. That event will not be live streamed, so if you're in Stockholm, make sure to buy a ticket and come over. Then if we look at the schedule ahead then, so I already mentioned 15th of October, Func Prog Conf. Then 11th of November, we are at Kivra. So also if you're in Stockholm, make sure to sign up and come to Kivra. And then in December, we haven't decided yet on what and when, but we'll come back with that. So, of course, you want to support the meetup group Func Prog Sweden, and you want to support functional programming, then you should head over to meetup and to YouTube and follow us and subscribe and etc. And also head into the Discord server where you can follow and discuss functional program with more people and also discuss tonight's live stream. And if you have questions during the presentation online, please use the chat in YouTube and Discord to ask them. And with that, let's get started. First guest and presenter, warm welcome, Erik Mejer. Hey, Erik, welcome to Func Prog Sweden.
Thank you.
You are warm welcome, Erik.
All right. So, hey, as already noted, I'm Erik, and I am a senior engineering manager at Maersk. And I've been excited about Elixir since around 2015, but I never quite imagined that I'd bring it into a company like Maersk. Yet, here we are, using it to help one of the biggest challenges of our time, decarbonation. When the energy transition platform, which is I'm part of, kicked off, we had to move fast. But in a company like Maersk, speed alone isn't enough. You need to entrust by working with security, architecture, hiring, and tooling from the beginning. Today, I'll share why Elixir made sense for us, what surprised us, and what it took to introduce it in a way that let us innovate like we tended to stay. Startups move fast, enterprises tend to move more carefully. So what if you need both? My personal journey with Elixir started back in 2015 when I picked up Dave Thomas's program in Elixir book. At the time, I was working at a small startup called Open Telehealth, and we were building systems to monitor people with chronic illnesses. We were a four-person development team, and honestly, it was not the most pleasant experience. We'd built a Grails monolith. We'd committed to staying up to date with Grails releases, but we'd fallen behind. And the development experience was slow and cumbersome, upgrades were downright painful. And on top of that, our customers were starting to ask for APIs so they could start building their own integrations. We looked at our Grails app and realized we couldn't separate views from business logic. So what were we to do? Around that time, Dave Thomas's book lands on my desk. I started reading it and I got really excited about Elixir and began convincing my colleagues, hey, let's build our new APIs in Elixir. So we did. We spun up services using Cowboy, built APIs based on its REST handlers, and layered some nice little element apps on top of that. And it worked out really well. The development experience was so much better than we were used to. And to me, it felt like we got our spark and our speed back. And that experience really stuck with me. Then life happens and took me elsewhere. I left for the Lego Group to play with toy robots for a few years. And eventually, an opportunity came along to help start a new platform at Maersk, the energy transition platform, created to support Maersk's ambition of reaching net zero greenhouse gas emissions by 2040. And that's when Elixir came back into my life. Before we dive into the technology part of this, let me explain why the energy transition platform exists in the first place, because the why really matters to me. Maersk has set some of the most ambitious decarbonation targets in the logistics industry, going net zero across all scope by 2040. And that's not just about ships, that's about warehousing and fuel supply, ocean and air transport, land logistics, and the list just continues. And here's the thing, 2040 sounds like it's far away, but the clock is ticking, and the decision and the progress we made today will determine if we hit those targets or not. Maersk realized that this couldn't be solved by isolated systems. There was a need for a shared capability, a platform to connect data, insights, systems, and software to support Maersk's work to decarbonize. And that's why the energy transition platforms and what we exist to support. So with a bit of context in place, we can talk about the choices we made and why Elixir became part of our story. So why did Elixir enter the picture in the first place? We knew that the hardest problems we faced weren't about fancy UIs, they were about data. Getting in from multiple sources, processing it, running calculations, integrating with other systems, and doing in parallel what used to be done sequentially. That naturally gave our work sort of a back-end heavy profile. But we also needed some front-end, or crucially, no native apps, no offline support needed. And I really didn't want two completely different approaches to testing for front-end and back-end, because I was pretty sure we'd need to shift focus back and forth between back-end and front-end. And we wanted teams separated by domain, not by a back-end front-end split. So is there a web framework that lets you do all of that without splitting your world in two? Yeah, there are a few choices, including Phoenix. And Phoenix, for those who are not familiar with it, gives you what feels like a fast and snappy single-page application for your front end without some of the hassle other approaches can bring. And there's another reason why Phoenix became attractive. It's opinionated. It gives you a solid skeleton to build around. And that's a huge advantage when you're spinning up a new platform and a new team, and you can't hire only experienced Elixir developers. And spoiler alert, we could not. And having that structure in place meant a new team would be able to onboard faster. So it was Phoenix that got us really looking at Elixir in the first place. The framework gave us a way to think about building full stack apps without splitting our teams. But once we dug in, the decision about Elixir wasn't about novelty, it was about fit. I am not going to spend a long time trying to sell you on Elixir, given that you are in a functional programming meetup, you were probably already sold. But in short, here are the strengths we focused on when we gave our sort of initial internal introductions. And I think it gives us a bit of insight as to where our heads were at the time. First up was developer productivity. Elixir is a batteries included language. It comes with a built-in tools for testing and dependency management builds. There's one way to write tests, there's one way to manage dependencies. And that consistency makes onboarding much faster and avoids some of the fragmentation you see in other ecosystems. Second, being functional, having immutable data structures makes the code easier to reason about. You'll know all about that. And immutability helps us shift focus from how data change to how data changes over time, not just what it looks like right now, which becomes important when you end up doing a bunch of reporting and audits. Third, resilience and reliability. Elixir systems stand on the shoulders of Erlang's OTP, so 25 years of proven patterns for building fault-tolerant systems. Supervisor trees mean systems can recover quickly from failures, and that's pretty critical for a platform like ours that serves sort of multiple user groups and needs while being a monolith. And finally, concurrency. We have to fit into the Maersk enterprise architecture, and that is inherently event-driven. And Elixir almost feels like a domain-specific language built for that situation. So in short, Elixir promised to give us speed, reliability, and a great developer experience. All things we needed to be able to deliver fast. But technology isn't the only decision when you start a new platform. Development methodology will matter just as much, and we chose extreme programming early and deliberately. We wanted a highly collaborative team, the ability to react quickly to changing priorities, and we knew pair programming would help us address some of the hiring challenges and complexity we anticipated. Technology and methodologies are not separate. They will influence each other. The right technology can reinforce the strength of your chosen methodology, and vice versa, the methodology can amplify the benefits of the technology you choose. And that's what we were aiming at, a virtuous cycle where technology and methodology make each other stronger. So just what are the highlights of extreme programming? At its core, XP is about short feedback loops and high collaboration. Key practices being pair programming, test-driven development, continuous integration and delivery, and the focus on small releases to get value out early and often, and collective ownership of the code. These practices, they thrive when feedback is fast, and that's where technology plays a major role. I just come off teams at Lego that did large React app while doing TDDing and pairing, and one thing stood out to me quite clearly, and that's waiting is draining. In React, you'll often end up needing the DOM. So you pull in something like JS DOM, and then everything slows down. And that friction from making a change to getting feedback from your tests that makes TDDing and pairing painful. And here Elixir is different. The tests are fast, even when you're testing your Phoenix frontends. And that speed makes TDDing and something like ping pong pairing enjoyable, not frustrating. And I know it sounds like a small thing, but it has a huge impact for how sustainable XP practices feel day to day, and played a major role in why we ended up looking at Elixir. So we'd set our course with what we believe were the right practices and the right technology. But in a company the size of Maersk, you don't just chart your own course, you navigate shared waters. You cannot just pick a new language and hope for the best. Maersk is an organization of around 100,000 people spread across 130 countries, and our GitHub organization has something like 5,000 developers in it. At that scale, you cannot always predict what you might break for someone else, which is why feedback becomes critical, because technology choices without that kind of alignment will end up building risk. At Maersk, there is a clear process for how we go about technology choices responsibly. before you start building, you engage with the enterprise architecture group. You sketch out the problems you intend to solve, what your architecture may look like, the technology challenges you're considering, and the non-functional requirements, things like performance, resilience, and security. And you also outline expected data volumes and what other systems you'll integrate with. Once you've got that in place, you take it to the architecture steering group for peer review. This group will bring together architects, engineers, and leaders from across the business. The goal is not to slow you down, it's to make sure you're not creating hidden dependencies or introducing risks that could ripple to other teams. It is also a chance to give others visibility into what you're solving and why you're making the choices you are. For us, the feedback we got boiled down to three big questions. Can you hire the people you need? Can you make it secure? And can you use our existing tooling and maintain your system in long term? And let's have a look at each in turn. The first question we faced was simple but daunting. Can you hire the people you need? Our target was 20 to 30 engineers. Our challenge is that Elixir is a niche language. If you were to look at the latest Stack Overflow survey, less than 3% of respondents reported having worked with Elixir in the past year. Our own market research suggested a global pool of around 20,000 engineers with Elixir or Erlang experience. Layer extreme programming on top of that, pairing TDD and collective ownership, and a Venn diagram of strong Elixir and enthusiastic about XP has a very small intersection. In practical terms, it felt like we had a handful of candidates who were both excited about Elixir and energized by pairing and TDDing. And with that comes the realization that we can't do a hire the unicorn strategy. The pool just isn't big enough. We needed a different approach. And it didn't depend on finding people who had both strengths. So we designed our hiring strategy around complementary strengths instead. We could not hire everyone with both skills. So we split into two cohorts. Cohort number one, XP coaches, people who live and breathe pairing, TDDing, small iterations, and can coach that muscle into the team. Cohort number two, Elixir experts, people who know the language, know OTP, Phoenix, and can teach those technical foundations to the rest of the team. This plays on a lesson I've had to learn repeatedly. Developers are great at learning new languages. However, pair programming is not for everyone. So rather than try and force a two-in-one profile, we built out the team by combining strengths and then cross-pollinating across the two cohorts through pairing and rotation. So hiring the right people means in this setup assessing for fit, not just technical skills, and that affects how we interview. The core of our interview process as we were onboarding the team was a 90-minute pairing and TDDing session. Candidates would bring their favorite language and editor, and we would bring a small problem for us to solve. The primary goal wasn't to grill algorithms. There are no width-like trees. There are no graph traversals. It's to see how we would work together. And we iterate through feedback loops smoothly. How do candidates respond to a failing test? Do they explain their reasoning and listen well? And do they enjoy the collaborative cadence of pairing? We wanted a candidate to experience our day-to-day reality of being an XP team and then self-select with eyes open. Is this a way of working where you will thrive? And we had some really strong candidates that did well and came back and said, listen, this isn't for me. I think that's a win. It saves us and it saves the candidates a lot of mismatches and hardship down the road. So this means we can focus on hiring the right people, but it does not solve a thin pipeline. We began by hiring across Denmark, UK, and India. This is where we already have a strong tech presence. We found some excellent people, but overall the pipeline was quite thin. Our breakthrough came when we could hire in Portugal. There's a comparatively strong Elixir community in Portugal, and I think Portugal owes that to an influx of Brazilian engineers, with Elixir originating with Jose Falim in Brazil, and it felt like striking gold. The density of candidates who were excited about Elixir went up, and our hiring pace accelerated. And this nudged us toward a critical operational choice. We had to go remote first and be as geography agnostic as we could, which brings us to what our team ended up looking like. We've landed on a distributed team across the UK, France, Portugal, India, and Copenhagen. We could not have built this team without a remote first mindset. And for niche skills in particular, local only hiring becomes a bottleneck very, very quickly. So what did we learn for this journey, and what would we repeat, and what we do differently next time? You will need patience. With a niche language like Elixir, hiring will take longer than the enterprise is used to. You need to plan for that up front. It is normal, but you need to let the enterprise needs to know that this is our expectation. Remote first is a non-negotiable for niche skills. It opens up the pipeline and lets you hire where the community and the talent there actually is. For our two cohorts, XP versus Elixir, in hindsight, I got to relearn that it's easier to teach Elixir than it is to teach pairing as a daily practice. If we were to do this again, I would probably strengthen the initial XP cohort over the Elixir cohort. And finally, when the pipeline is thin and the pool is small, retention matters even more than it normally would. And developer happiness matters. Elixir shows up as a most loved language in the Stack Overflow surveys quite consistently, and our turnover has been astonishingly low. There are multiple factors behind this, but we know that developer happiness contributes directly towards high retention. And Elixir and Phoenix score high on the Stack Overflow questions of would you like to continue working with this technology, which would argue that both Elixir and Phoenix are quite enjoyable to work with. So overall, the principle is simple: hire for complementary strengths, and you need to build for balance. And design your process to reinforce the culture you want, not just your skills you need. So we had a team in place. The next big question was, can we make this secure? And if there's one thing we did right, it was to engage early with the cybersecurity team, even before we started bidding heavily on Elixir. Their job is incredibly tough, especially in an enterprise as large, as complex as Maersk. You don't want to make it harder. So we started the conversation, the cybersecurity team, before writing a single line of production code or even settling on Elixir. And their initial feedback from cybersecurity was clear. You won't fit into our standard security tooling, and we can't provide the same training support as we normally can. And that was a bit of a reality check. The question that came back to us was, how do we solve that? All about collaboration and not about roadblocks. So for us, we knew that promises wouldn't cut it. We're a new team, a new platform. We had to show that security could be baked in from the start. So we pulled in Potion Shop, a deliberately vulnerable Phoenix app. We made very sure not to deploy it anywhere, and build a pipeline to prove that we'd be able to catch the vulnerabilities that are present in PowerShell. And we didn't stop there. We integrated our pipeline into the reporting tools cybersecurity already work with and trusts. And that was key. They can't know the details of every team. We can't expect them to know Elixir, but we need to build confidence that they know we're doing the right thing. So we focus on making their life easy. This is sort of the bare bones foundation we rely on to keep Elixir apps, our Elixir apps safe and healthy, where we couldn't rely on standard tooling. So it's mix compile, warnings, errors, git, catch any warnings at the outset and just keep errors away or warnings away. It is mixed steps audit. So we scan for vulnerable dependencies. It is mix so below, which will scan Phoenix apps for the OWASP top 10. And it's mix hex audit to flag any retired packages. Together, this forms a lightweight but effective baseline that is, of course, only part of our overall security stance. So we've proven that we had replacements in place for standard tooling where needed. But when you as a team decide to step off the paved road, you also own the security training. On mainstream stacks, though, you'll find plenty of off-the-shelf enterprise training. But as soon as you choose a less common technology, that support disappears. So we've had to build our own learning path. And we're leaning heavily on the work of the Erlang Ecosystem Foundation Security Working Group. Their resources are sort of the backbone of our security training. There is the Elixir Secured Coding Curriculum, which is designed for enterprise use. That's us. And then there's the Secure Coding and Deployment Hardening Guidelines and Web Security Best Practices for the beam. And all of this is required reading for our team. So what did we learn? Engage early and often with cybersecurity. They are partners, not gatekeepers. And when you choose to step off the paved road to take on extra responsibility, build security and you build training into your plan from day one, Elixir is exciting and security is non-negotiable. If you want to move fast without breaking trust, start with security and never stop investing in it. It's the security is the checkbox. It's a culture approach. And when you decide to choose a non-standard stack in an enterprise, you own that culture. So we have our team. We've made sure we can build something that's secure. The last big area of concern was around tooling and maintenance. And we got some fair questions. If hiring is hard, can you maintain your systems long term? Will your system fit into existing tooling, or will you have to rebuild everything yourself? And what about the smaller ecosystem? Are you taking on extra risk? So let's break down what we found and how we decided to address it. First, long-term maintenance. If hiring is tough and you start small and someone may decide to leave, you can't just pull in the next door .NET engineer overnight. And that is certainly true. But what we found quite quickly is that the complexity of our domain and the organizations far outweighs the complexity of learning Elixir and Phoenix. Engineers are good at picking up new technology. So we were convinced that we were not taking on any significant additional risk. Second concern was around the ecosystem size. Elixir is smaller than Java or .NET, there's no question. So we tackled that by doing our homework. We identified the critical dependencies and had a contingency plan in place. We know where our risks are, and we are ready to step in if needed. And so far, Phoenix has been solid. It's probably one of the best maintained Elixir projects around. We do have some components flagged as risks. We are still fine, but there are still things on our watch list. And then we come to the tooling questions. Will our choices fit into existing tooling? So we start out by mapping the landscape. Right, hosting and monitoring, there were easy wins. At Maersk, if you can run it in a container, you can deploy it. And for monitoring and observability, Phoenix integrates well into the existing observability stack. Builds and deployments, also easy wins. They're just GitHub pipelines. We can build those. The design system was much harder. The design system gives us a shared component library for our UI. It is optimized for JavaScript frontends, React, Vue, Angular, and so forth. And our users navigate across multiple internal systems, so consistent UI UX is important. And to get that consistency, we've just had to port components over to Live Vue as needed. Not free, definitely doable. This turned out to be much less of a challenge than we had feared. And I think the reason we didn't face bigger challenges at Maersk is that Maersk is not a technology monoculture. So all our tooling teams already support multiple stacks. So they're used to making technology agnostic choices. I've worked at places where everything was optimized for one stack, say Java Enterprise. And introducing Elixir there would have been a much harder sell. Not because it's impossible, but because I'm not sure I could have argued that it makes financial sense to duplicate all the tooling investment already made in a company like that. Even with all that alignment in place, there were still surprises. And I think sometimes the best decision you can make is to change your mind. I was sure we would end up using Broadway. If you were to look at our initial architecture drawings, Broadway was in every single one of them. It's an amazing library. We're building concurrent, multi-stage data ingestion pipelines in Elixir. And given how much event-driven data we expected, that seemed like a no-brainer. But here's what happened. We didn't use Broadway. Instead, we've ended up using an internal Python-based tool for data processing. And honestly, it is fantastic. Other teams were already using it, so some of the data we needed was already flowing through it, which saves us a ton of effort. I think this is a critical lesson. Do not become target fixated. Do not pigeonhole yourself as the Elixir team. We chose Elixir because we believed it was the right tool for our core problems. But you owe the company the honesty of knowing when it isn't the right tool. Not because Elixir can't do the job, but because other solution already exists. You shouldn't be spending your effort building a pale imitation just to stay pure to your initial vision. So yes, we did choose Elixir, but we don't use it everywhere. We use it where it makes sense, and we're honest when it doesn't. That's the real story to me. It's not about a language, but it's how you innovate responsibly in a big organization. Because when the stake is high and the clock is ticking, it's not enough to move fast. You have to be able to move fast without breaking trust. And let me leave with the principles that we've extracted out of our experiences. First, engage early. When you work in an enterprise the size of Maersk, you cannot predict every dependency. And feedback is not a blocker, it's a safety net. The earlier you bring people in, the easier it is to build trust, and the easier it is to avoid any surprises. Second, own your choices. When you step off the paved road, you take on extra responsibility. That means building your own training, proving your own security posture, and making sure that your tooling story holds up. You cannot outsource that accountability. And finally, it's all about balancing speed and trust. Innovation isn't just about moving fast, it's about moving fast without breaking the enterprise. If you can deliver quickly while giving stakeholders confidence, you create a virtuous cycle. Trust will buy you freedom, and freedom will let you innovate. And that's the point I'm trying to get across here. Elixir is a tool, but the story is more about how we innovate responsibly inside a bigger organization. And with that, thank you. And I think we may have time for a few questions.
We do. Thank you very much, Erik. Loved your presentation, and I loved your slide, like why Elixir developer, productivity, reliability, and fit. It was really nice. We have 2 questions so far from the chat. Like, first question was like, I hear people say the lack of good debuggers is a deal breaker, but most don't understand the concept of using the shell is in live system. How do you convince the stakeholders?
You can do it by showing it, right? So we did have that kind of question. How can you, if you don't have a debugger, what do you do? And then you show them a production system, and you connect in, and you open up IEX in the production system, and you start looking at what's actually going on, and that's a fairly strong argument we found. So not a deal breaker on our end. Do lots of demos would be my answer.
Thanks. Next question. How do you perform pair programming while working with a distributed team and so working remotely?
Yes. So we use Drupal, which is an app specifically for doing remote pair programming. There is, of course, a challenge that we've got about half the team in India, which is 3.5 to 4.5 hours ahead of the rest of Europe. So we do, the teams are all, we have 4 teams running, and they all have members of both in Europe and India. So we pair program with the folks in India in the morning, and then it's strictly European pair programming in the evenings. And then crucially, make sure you do good handoff comments and notes at the end of the day. So that the team in India can pick it up in the morning. And I think that's worked out fairly well. Also, when you do XP, you try and build as small things as possible, right? We try and do tiny increments. We push them straight to the main branch and hit production a few minutes later. So you don't have these sort of long running tasks. We try and get them into as small increments as we can, so we don't have to do any handovers that we don't need.
Thanks. Final question. What part of the language has been the most helpful to you? Like the expressiveness, the fault tolerance in OTP, the ability to hot load code, or something else?
So we don't hot load code. So not that one. I think it's the expressiveness. And I think it's not a language feature, but it's a feature of Phoenix. I think live views have served us really well. I think letting users work on systems where things just update on their own as stuff happens in the background has been a really strong selling point on us, and they get quite excited when they see that happening the first time, that they're working and someone else is working, and then suddenly numbers change on their page because someone else is working on the same thing, and that excites people. That kind of activity.
Cool. Again, thank you very much, Erik, for your presentation. Very nice presentation. Thank you very much.
Thanks for the invite.
Yes, of course. And with that, we will head over to our next presenter and our next presentation. Welcome, Felix, to Func Prog Sweden. Hello and welcome, Felix.
Thank you.
Warm welcome. The stage is yours, and you're going to go on with Electric, Clojure plus Rama. Very interesting.
Thank you. Long time lurker, first time presenter.
Yes. Very exciting.
It's just to loop in on Erik's talk. I think it's amazing that you're actually doing extreme programming at such scale, and the thing about doing a production, like you sneak into the production system and do some changes, that's a Clojure thing as well. I remember doing that just a couple of weeks into my time at Multiply, which I'll talk more of. But thanks for the presentation.
Yeah, you're welcome. The stage is yours.
Grazie. So Electric Clojure plus Rama, a Clojure stack from the future. My aim with this talk is to, like when you leave for dinner or whatever tonight, my hope is that you will know a bit more about Electric Clojure and Rama on a pretty high level. I'm not going to go that deep into the nitty-gritty details because I don't think we have time. Both of them are pretty out there in what, at least to me they are, in what the current state of web development and back-end development is today. And they allow things that I wasn't that used to when I joined Multiply. And this talk will be much more of an experience report, because I reflected on how the use of Electric. I'll just show you. I'm getting ahead of myself. So this is what the talk will be, and I'll start with the Electric part of the code, because it will be in Electric where we are building all of our UI, and Electric also has a little finger in the back end, which I'll get to. Then we'll move on to Rama, which is basically backend plus DB, and if we have time, I'll also touch on some in-house glue that we have on the JVM that kind of glues it all together nicely. It was a baby project of Henrik at Multiply, so it was all in place when I got there, and I find it pretty amazing. Cool. So I've been doing development, both front end and back end, for about 8 years, and the general setup is usually you have some front end code, you have an API, and you have a server doing some things on the back end, kind of hidden from the user. And the API could be either REST, it could be GraphQL. It doesn't really matter in this to get this point across, but that's usually what I've seen. And the client makes a request, gets to the server server gets you a response back to the client, and that's the cycle you kind of live with as a web developer, or a full stack developer rather. But with Electric, it's a bit different, and with some reflection before this talk, like, okay, so I'm going to do an experience report, it's going to look like this. I kind of realized that I haven't thought about an API in about 4 months now, since joining Multiply. And that's kind of a freaky idea, I feel like. And but definitely an interesting one. The YouTube video at the very bottom, I couldn't really get that animated in at the very end, so it will just hang out there at the very bottom. But you can check out if you want to multitask some. You have a link at the very bottom of the slide with the Electric Hyperfill 2 clocks example that I'll talk it through now with some visualizations. But if you want to have a sneaky peek look, you can feel free. So instead of an API here, in the middle of the client and the server, we have some, Electric Clojure code. Looks very much like Clojure. but with these e/defen, e/client, e/server, e/client. And what this does is it analyzes the code and let's see now, the full example that is in the YouTube video and that some of you might have seen in the 2 clocks example, it's just one file. Like you don't have any front-end files, you don't have any back-end files. You basically write out your UI and you shimmy in some back-end code. And that's all you, like the developer experience, that's all you do. And it is pretty bonkers. So you can see here we have some server code. It's something that calculates the system time on the back end. And it runs, obviously, then on the server. And at the same time, we have the rest, which is client code. And it runs on the client. And Electric takes care of all of the syncing between the server and the client with a WebSocket connection, which keeps everything in sync. So we have I was trying to communicate here that we've named this variable S, which is the server value of the system time. But that S value is gonna need to pop itself over to the client. Electric does this, like that. And it gets to the client now as client S, and you can see a little recording down here with the server time being calculated over here on the right on the server, and the client time along with the skew of like the diff, like the network hop diff of between the server and the client, and that's the time it takes for the WebSocket value to travel. At least when I was on a bus or something, so I had a bit of latency. But it's pretty cool because you don't like the notion of not thinking about the API makes me at least go so much faster with developing these things, because I know the UI, this is what I'm looking at, and I have some backend functions that are already there, or I can just create a new one, getting some data from the database or whatever it is we do in our everyday work. But from more intricate example from the multiply code base. Some background. I don't want to take this spot and make a lot of PR for the company, but it's useful for knowing what the platform is for and the what's the word? Like the definition of the attributes. What is there's a word that I'm looking for, but the attributes for what we're building. Basically, we need some asynchronicity. We need some this and that. And what multiply is a AI agent orchestrator that is used from creative agencies. So you can imagine that there are AI agents all calling on each other left and right, starting a workflow, leaving that workflow onto another agent and doing something else, all asynchronously. So, for example, this is the landing page. We have a list of recent projects right here, and we're going to have a look at that code. So the main view, do you think this is a good size? No? So we get it up there a little bit more. So you can see here that if you squint, it's basically HTML. If you compare this view right here. So this is the first section, this is the grid project section. And moving along down here to the grid project, we go to that definition. We can see we're still on the client. We move down here, and a small spoiler alert, the server jump is done at the spaces right here when fetching the recent spaces. Everything else is client-side code. So the interesting part here is inside of recent spaces. We head in here, and we have some arguments, whatever. I'm not going to touch this Clojure feature, but down here we have the actual server-side code being run, and it fetches the recent spaces. We're pretty quickly inside of this function heading into Rama territory, which we'll get to later. So I'll just hop back here. Another example here is the on-click functionality on the back end, but you click the button on the front end and something happens on the back end. That's something we're all familiar with in our day-to-day job. So getting back to that, it's in the create atom section, still in the same page. We sneak down to this run function, which is being used further down. This part right here is the primary button. That is the thing that runs it. And all it does, if we jump back up, all it does is it does a React-like thing here, which we've implemented as a hook within Electric. We set transacting and we get the transacting value. I think a lot of people are familiar with this pattern. So when we push the button, transacting gets turned to true. This code gets run on the client side still, but this part right here is the thing that actually creates the prompt which we wanted to. So if I didn't communicate this, it's a prompt box here. You write something for an LLM or an agent to do, and then you run it, and you will get rerouted, and this thing will get created basically. So going in here, we have some server code. There's some thing here that will go into Rama territory, so we'll get there eventually. But I'll touch on these things when we've talked a little bit about Rama. So Rama comes next. What a surprise! It has been mentioned by Nathan Maersk, that is the founder of Red Planet Labs. That's the company behind Rama. He fiddled with this for 10 years before releasing the private beta that we're using right now. Yeah, there's a lot of cool things like in this platform. It's interesting that he calls it a platform. It's no library, it's no framework. It is something that you have to buy into, and you have to accept that it looks like this. It's very opinionated, but at the same time, it's generic to a point where you're free to form it to whatever shape you want to, if that makes sense. He's also shaped it to people not knowing what it is. It's, if you want to kind of focus in on it a little bit, it's stream processing and DBs. And that's databases in plural. First time I said that word out loud. But as many, it's DBs. It's many of them. Distributed data stores. It handles deployment, monitoring. It is scalable, and also fault tolerant. The scalability and fault tolerance, I don't think I know that I won't have time to get into, nor the deployment, nor the monitoring. But the thing I'll focus on is the developer experience of the stream processing part and the creation of databases, which we'll get into next. It is at the very base, at its very core, it's an event sourcing system. So to get data into the system, you have to do that by events. And Rama has it has its own nomenclature, but I want to just touch on how event sourcing works. So it all starts with an event log. I worked at an amazing telecom company called Telnus years and years ago, which had their hand-rolled event sourcing system. And they had just one event log, a Postgres table that did all of the event handling. And a lot of listeners then, acted on the new events coming in. But usually, I mean, that's my experience, and to my feeling of it is that many people use one event log. And they push in some customer created, some customer name set, like events about customers. And then you have your orders, you have whatever it is, but they're usually in the same event log. Then you have a listener that handles each and every event, and you do some data transforming, you might do some side effects, it might end up in the database, it might be a third-party service that gets contacted. But this is usually the flow that you're looking at in an event source system, not touching on the querying part of everything, but the feeding into the system with events containing data of different kinds. Usually domain events. So if I was a seller of some sort, or I had a store of some kind, I'd want to create customer, I want to create an order. You get the point. So Rama's event sourcing, I want to talk about how it maps onto this, onto the event sourcing that we just talked about. So instead of an event log, Rama has depots, which is the exact same thing conceptually. You push events into them, and you then read those events and you handle them in an ETL. It's called in Rama, but I'll get to it. It's usually grouped by entity or business use case or feature. So it's not one huge event log. You can create how many depots as you want. So for this example, we used customer and order. You'd probably have a customer depot and an order depot, each getting their events sent to them separately. So we won't mix any order events into the customer depot for obvious reasons. There's a separation of concerns aspect of this, because when you handle the events from a certain depot, it's pretty nice to only have that space of the flow in mind. Like there's not going to be any side effects coming in. It's just going to be basically a function of the event data coming in. You do your transformation, you do your thing, and then you store it somewhere in some kind of data store. So moving forward, we have the customer topology and we have the order topology, which is, as I mentioned before, the ETL, like the data transformation part of this, where you handle each event, you do your side effect. And in Rama, it's the data store that you use is abstracted in as a P state, a partitioned state. So the state, we'll get to it. It can look however you want, basically, based on how the feature and constraints of your feature, like the thing you're gonna build. However that looks, you can shape the data that you're storing custom to that use case. And this is basically the three things I want to underscore. So depots, topology, and P-state. These are the things that are, to me, very interesting to understand the data flow and storing of the data in Rama. So let's zoom in a little bit on the topology part, where we actually have Rama has a beautiful DSL for some really cool things. Like it's mind-boggling what you can do with this DSL with just a couple of lines of code. But first, I want to talk about an abstraction that comes up in Rama called a fragment. So a fragment, we all know, well, we don't all know fragments yet, but we know functions, which you can kind of see as a call and response kind of thing. If it's a pure function, it can get one or more arguments to it, but let's not talk about that. I just want to visualize this. Something comes in, something happens, and something is pushed out, or not. If you just want to return null or whatever it is, you won't return anything. But pure function, we go by values, we return something. A fragment is an abstraction over this, where a function can be a fragment, but a fragment in its case is same as a function. You get a call site, or you're at a call site calling the fragment, and the fragment then emits nothing, as the function could also do, or it emits once. At this point, it is now a function. Like, this is the implementation of a function using fragments. It's a call and one emit. Or you could emit multiple times to different subscribers. And if you squint at this, you kind of start looking at this data flow model that is talked about when if you would go and read Rama's documentation right now. The part between an event coming in and it being stored in a P state, this is basically what it is. It's a data flow programming paradigm that sits between these two parts of the system. And that's what the DSL of Rama does. I'm not sure what you would call it, if it's an ETL DSL or whatever it is. It's a beautiful thing. So you have the event right here. Then with the DSL of Rama, you push things into a P state. Or not visualized here, you could go for a third-party notification or whatever it is. So, a P state, you could explain it or describe it as a data shape and nothing else. Because some features of your system would maybe be best expressed, and the data of it being stored in a key value store, which is just a map. It's nothing more than this, basically. There are a lot of providers of key value stores, and you could use any of them, but in the very essence, it's just a map. If you would go on to look at the document DB, or a document DB, it's a map of maps. That's what it is. And the shape of it, we can kind of imagine, would be something like this. It's a document ID linking to the contents of that document. And I'm not going to describe all of the different ways of describing an edge database, or a graph database, I mean. But there are ways of doing this within the P state shape, where you link an edge to a node, and you could have, you can describe amazing things with this abstraction. But I didn't get the time to get it into this slide. But we have an example from our code base right here. So this is the P state of our accounts, and as you can see, it's a map. We can see as much, and each key, or rather, each key value is connected to another map. So this is basically a document database right here. The content isn't that important, but this is what we use to describe and store accounts in our full system. And nothing more about it. Like, this is all we did, and we can reason about the accounts just by looking at this and reasoning about what events do we need. Like, do we need a set status event? Do we need to add an email? But it's nothing more. It's just this flow of data from an event through this data flow programming paradigm into a P state that can look however you like. So going back to this dashboard and looking at the list of projects, we're now going to peel back a little more from the recent projects functionality and that UI, how that works. So we was at the project grid. We're gonna drill down to recent spaces. We're gonna go into the recent spaces. It's a function right here, and it's a query. We're now at the server. I believe, yeah, we marked this as a server code here as well. But you can nest it however much you like, and for the sake of being explicit, it's kind of nice, I think, at least my opinion, to mark them on each level. We get down here. This is a little teaser of the glue code that we have that I might get time to talk about. But it takes the output of the Rama query on the topology. If you remember, the topology was the topology is the data flow paradigm between the P state and the event. So going back to the dashboard, we go into the recent spaces function. We have a look at the topology query right here. So as a Clojurist, I thought this was ugly. Like, this made no sense to me when I started looking at it. Only when reading about the fragments abstraction, I kind of could sleep better at night, because it's so cool. I haven't talked about this with Rama yet, but this is basically the input. You have this partitioner hash right here. So Rama actually orchestrates different machines to store data in a. It kind of says it by itself in by naming the P state, partition state, that by the org name or whatever you decide, it could be a UUID or whatever the value of org is. It hashes that function, and from the hash, it knows where to emit that data. If you remember the fragment, it emits one or more times or none. But the emission here could be to another machine. And that makes all of the org data that we have at Multiply, it gets stored at the very same place. And we can join through that data, since it's different P states along all over the system. We can join this data together in a manner where we don't have to do another machine jump. Like, we don't have to go over the network to fetch everything. Everything is co-located in some manner. So this is what that tells us. Please go to that machine where we store all of our org data on. It could be Multiply, like a string. It could be whatever, but it's hashed and it goes to that place. We check if we have a query. In this case, we don't. But you could search the recent spaces for the name of the space. A space is a project. Should have told you that earlier. What happens here is we don't give it a query. We make a local select. It's part of, you that are familiar with Spectre in the Clojure sphere, it's very similar to Spectre, the Rama API. If you know Spectre, you can probably get up and running in no time. So we have the spaces with the path. We already have the org as an input. We have the account, the max amount of projects that we are supposed to fetch. We set this in a variable like this. We park it here, you could say. And then we reverse it to get the last modified project, and we return it to the original caller, which we see here. So going back, like that. The the value that gets returned is a completable future, a type in Java, and our glue, which I probably won't have time to talk about, it takes in this completable future and turns it into this domain-specific or code-base-specific entity that is basically a completable future, but with some added semantics to it. Basically, in short, we need some, since agents are in its essence probabilistic, we could have an agent that goes rogue and starts a lot of other agents and does whatever. And this task, completable task type that Henrik has created, it's basically, it allows us to, if we cancel it, basically, if we cancel that thing, all of these subtasks that has been created from that task will also get killed, which is not the case with completable futures. Then it's just one of them, but all of the subtasks still live and has to be garbage collected somehow. Cool. Sneak peek into that. The sending of a prompt to an agent, I think we'll skip, but it's creating a task, the thing that a completable task, and it asynchronously starts a conversation with an LLM that then decides through tool calling, etc., whichever other agents it might need to activate for the prompt to get investigated, usually. With our clients, at least, it's investigative work or it's some creative aspect that they want to explore. Okay, cool. The summary, I think I'm in time, maybe. Cool. I'll summarize, and then I'll show you or talk more about the glue code that we have. So, like, there's no API. Like, I haven't thought about an API in ages, I feel like. It's pretty amazing in the speed or velocity that you gain just by creating your new UI and creating your backend function, and everything else is just handled. And with Rama, it's the thing that I'm the least seasoned with so far, but what I've seen is simply amazing. Like it's like Electric in that you don't have to care about the API, but all of a sudden you get event sourcing for free, which is an amazing thing, that alone. But then having the DSL of the data flow paradigm to decide which machine something is going to execute in, it's crazy, the things that you can build and the things that you can scale with that DSL. Yeah, that was it. I forgot to add an ending slide, but the task as flow, it's right here, as it says right here. Since Rama returns completable futures, and by that essence, it allows for subscription of the P state, we can define it like a flow right here, like a flow of data. You could kind of imagine it like, and the recent spaces will in turn return this value, and Electric then takes hold of the value and returns it to the front end. And that was mostly the thing that I wanted to communicate here, that it's so cool that you can have the client and you can just have data streaming without having to think about it. from the browser to your server to your database and back without having to write any custom code. Yeah, that's Elixir, Clojure, and Rama. I think I'll leave it there. Thank you.
Thank you. So now we're going to head over to some questions. You can read them on my screen and I can read them for you. So, someone asked, is Rama open source? No, but it has a free tire. Apparently someone asked and someone answered in the chat.
Yeah, they're doing a private beta
Hmm?
as of right now,
Yeah.
which is what we're on. But there's also a free tier. I think if it's you get 2 nodes, so you can split the workflow that I talked about. You can split it into 2 nodes, like doing the computing. And I think you have to be. I'm not sure if there's a company size or something like that, or in the license that you have to be mindful of. But you can use it today. You can try it out today.
What's being used for routing between server client? Is anything, or is it just magic glue? You don't think about it?
It's rated. Did you mean the routing?
Routing. I guess they meant the routing between the front end and the back end. I think that's what they.
So what page you're viewing?
Yeah. I
That's
mean, somehow you ship data between in the socket.
the socket you don't think about.
Okay.
It's not. That's the electric magic.
Hmm?
The e/defen. So in Clojure you usually define a function as a defen, but the e-defen is a macro that analyzes everything. So that's not up to me to think about how the routing of data gets handled. I just define it and it magically appears. I kind of find it I'm a bit two-sided about this, because you very much relinquish the authority to have a say in how it's done, but at the same time it steps out of your way so much that the trade-off so far, what I've seen with the system that we've built, that is heavily asynchronous, and to me it's worth it. They had some earlier versions that they've now battle tested, and it's so far my experience, it's been really good.
Cool. Is it possible to attach new listeners to the depot and replay already happened events?
Yes, so you can stream. You can add how many of them you want. We did this for an index of the agents that we split it basically. We had all of the agent data and an index within the P state, and we had done a mistake in how we serialized the data to Rama. So some ordering wasn't being handled correctly. And how we solved that was that we created another topology that read all of the events in that depot and spat out all of that data in a correct manner into a new P state called agent index or something like that. So definitely.
My own question, which AI agents are you using? Or is that secret, or is it open?
No,
Multiply.
it's up to the customer.
Oh, it's up to the customer.
So we have integrations for GPT-5 and all of the latest models.
Cool. Are you yourself using any agents when coding, or models, or Perplexity, or whatnot?
I'm a big Claude user.
Oh, Claude.
So both Claude Code, but also the so B. Hauman released Clojure MCP, which is a MCP server that hooks into your running REPL and the running system that you have. So the LLM can evaluate code that it sees fit and kind of explore the system alongside of you. And that has been a very, very cool thing. You can say things like, can you please fetch me the data from this database? I don't really know what it looks like, but I'd like to see the shape of it. And it just does it. It's magic. But there's brain rot accompanied with that the way of using it. So I try to spend some time and think a lot about what the AI spits out, but also, what do I think of these things? How would I design it? And get input from the AI in that manner.
Yeah. Final question. Electric helps as things get complicated, but Rama can send any shape of data and keep things simple. Why use Rama with Electric and not with React or hypermedia frameworks like HTMX or Datastar?
I mean, good question. I wasn't there when the decision was taken to go for Electric. You could definitely go for HTMX. I can see that being a very good solution for these kind of systems as well. I'm not sure. It could be. So when you prompt, you saw the prompting screen that I had in my slides. When you write a prompt and you run it, you get into this other view where you can kind of see the agents go at it and spread out and research that thing over there, and that other thing is happening over there. I'm not sure if HTMX would suffice for that interactivity and that, that visual updating, or it could. I've just played around with HTMX, so I can't tell you. What I can tell you is that Electric has done a very good job so far, but other tools would probably work as well. Pros and cons.
Thanks. I think that kind of concludes all. And thank you everyone for also watching tonight. And thanks again, Felix, for coming and presenting. Very interesting. There's one more question for the previous speaker. Please jump into the Discord server and ask it. We can answer it there. And again, thank you everyone for watching either tonight, today, or morning, depending on where you are in the world. So have a nice time, and until next time, bye.